so then let's move on to how to use random walk, or kind of still the PageRank actually, with add some personalization to it, right? Because when we look at the Google search engine or search some terms, I don't think we all end up with the same ranking. Especially if I keep searching some terms, I guess it will become more and more relevant to what I want to find. So how can we transform this problem to a personalized problem? So think about personalization, then the first thing come to mind is recommendation, right? So it's like an item user interaction graph, right? So here's the item and here's the users. And then the interactions is all just between the items and the users. And the link can represent purchase or click or like, comment, or any interactions that the user has done to the items. And then we want to figure out, so what items should we recommend to a user who interact with the item queue, right? So if this user has, which user? Yeah, maybe this user has interacted with item queue, then what other items shall we recommend for this user, right? And then one intuition, and also I think the same intuition from the collaborative filtering algorithms, right? So if this item Q and P are interacted by similar users, then we should also recommend P, because Q and P, because the users who interact with Q also interact with P. But if this user hasn't interacted with P, but then P will be a very good candidate to recommend. So still, I think the same logics with the collaborative filtering. And then if we just think all of this as a graph problem, right? So which is more related, like A prime or B prime over here, right? So it's very hard to see. So then let's see this structure. So you see the A and A prime kind of, they share the shortest path, maybe just 2 links, right? But for B and B prime, they actually share, you need 4 links to jump from B to B prime, right? So you will say, well, A and A prime is more related comparing to B and B prime. And then how about C and C prime, right? So C and C prime also share, well, the shortest path is still 2 links, but they have so many short paths, right? So not just one, they actually have 2 or 3, right? So it kind of getting more confirmation that C and C prime is very related. Right. Now, how about D and D prime? Well, D and D prime has a very similar structure with this, right? So you see it's this cross structure. The D and D prime also share the common neighbors, but because these neighbors have so many, has interacted with so many other items, and comparing to this, well, their common neighbors only interact C and C prime. So this is less informative, because say this user just loves everything, then the information that we get from this user, like this specific one item, then is very small, right? Because just this user just loves everything, then it's really no additional information provided if this user just loves this specific one. So how can we take into consideration of all this, structure of the graphs? So the original PageRank, just as we showed earlier, so we want to rank the nodes by importance, and then we want to, and also from the random server point of view, it actually can teleport with the uniform probability to any node in the network. Well, for the personalized PageRank, we can just rank the nodes while it's still a ranking problem, but it's with respect to a certain set, right? Say certain set of nodes S. So the set of nodes is not any node. Right now become a set of nodes. So right now every time when we jump back or randomly jump, so it will not jump to any node over the graph. It will be teleport to a specific node in this set S. So it also calls the random walks with restarts, like restarting from a specific set or a specific starting node. Yeah, so the idea is, I mean, this is still the same, right? But here, what's additional to our previous PageRank is we have these query nodes, and we simulate a random walk, right? So every time, still we just randomly follow a link or teleport to a random node instead of teleport to any node of the graph. We kind of teleport to the set to one node randomly in this set, in this query nodes set. And again, we can still like doing this infinitely, and maybe not indefinitely, but we can do this like many times, and then we can record the counts of the nodes, and then that nodes right now, that importance of the nodes with respect to these query nodes. So it's not the global importance, but the relative importance of the node with respect to this query set. Yeah, so this is basically given a set of pre-nodes, we simulate a random walk. Like every time with the probability that either randomly following an outgoing link or will jump to one node or jump back to this query node and start over again. So here it just shows this user item interaction. So we have a query nodes. So it can be a set or it can be just one node, right? And then we just randomly sample one node from this set, which gives us an item. And then we do this iteration n times. And then this item, we just randomly get a neighbor of this item, then we reach a user, right? And then from this user, we randomly get a neighbor, which gives us another item. And then we visit this item, and then this item visit counts to +1. And then at probability of alpha, we will jump back the original item. Right? So we can, so if the with 1 minus alpha, we will just do this iteration. It will jump everywhere. So we will hop between user and item over and over again. But with the probability alpha, we will restart from the one node in the query nodes. Right? So we will get say Q again, and then continue the process. Yeah, so this is what it shows. So the benefits of this algorithm, the similarity actually, although it's simple, right? It just teleport or randomly jump back. But the similarity actually considers multiple connections, the multiple paths, the direct indirect connections, and also the degree of node, because all of this will be reflected in that random selection of the node of the neighbors, right?
Why do we do the random jump to the queue nodes? What is the idea behind it? Yeah, the random less than all.
So why do we? You mean why do we randomly restart from queue?
Restart.
Yeah.
Yes.
Because
yes.
yeah, because we want to. Right now is not a global importance. Right now we want to identify the say this is item, right? So right now we want to identify the items are important to queue or very similar to queue.
Okay.
Yeah, so if you always restart from queue, those ones similar to queue will get more chances to be visited by the server, right?
Yeah, so the ones which are farther from queue will not be visited. Like
yes.
If queue is related to, let's say, 1 with 3 connections, it has less chance of getting visited.
Yes. Yeah.
Is that the goal?
Yes.
Okay. I see. Okay.
Yeah, that's the whole point of jumping back or restarting. so that we can add more relevance or more similarity to the nodes that are close to Q. So here we show there's some variance of PageRank, right? So in the PageRank, it always teleports to any node of the graph. And for the topic-specific or personalized PageRank, it will teleport to a specific set of the nodes, right? So say this is the set. So in the beginning, it's a uniform distribution of all the nodes, right? But here, for the personalized PageRank, maybe it's a selective set of the nodes, say just these 4 nodes. And every time with restarting, we can just randomly pick one of these 4 based on this probability vector. And then also we can just say always jump back to one specific node, and then the vector will become just one value, like just 1 for this node where you want to always jump back. Yeah, so that's the whole slides that I want to show, right? So we have seen the PageRank, and I think most importantly, I mean, it's a simple algorithm, but I think most important is to see the relationship with the random walker and also with the like the adjacency matrix, the principal vectors of the adjacency matrix. And also it can be solved by these power iterations. And then we see a variant of the PageRank, the personalized PageRank. Basically, it's kind of slight modification of the random walk with the restart problem. And also there's a highlight on the slides. It says that viewing the graphs as matrices play a key role in all the algorithms, right? So you can always represent these operations or these probability vectors, in vectors and matrices. Yeah, so I'm going to show some quick coding example next, and also for you to further explore if you want to, try it out on some graph data and use PageRank to rank the nodes, and even do some recommendations with PageRank. So I'm going to show some coding example next. So before doing that, so any other questions or comment? Okay, so anyone?
I wonder how this is related to like machine learning or deep learning, where it's more about data and stuff like that.
Yeah, don't think it's, this is not related to any deep learning so far. It doesn't have any deep learning so far. So it's just a pure graph algorithm based on the links, based on the link analysis.
I see. But somehow in future in this series, we are gonna talk about how this is related to machine learning and stuff like that, like deep learning and stuff like that.
Yeah, so from the next meetup, we are going to walk through the graph neural network, GNNs. Yeah, from the next one, we will go through. And maybe after a while, we will maybe revisit some of this to see if this problem can be also formulated using the graph neural network.
Okay. I see. So the same problem of ranking pages can be solved with graph neural networks and see the performance and stuff like that. Okay.
Yeah.
Question about the personalized ranking. Just want to make sure can understand that one. So this one we don't get any features because that's kind of for users and the item or product recommendation. So for that one, we don't get any features about the user or features about the items for modeling purpose. This is just based on the user item widget pattern there we want to find for this user, we know it visit item Q. What are other potential items this person may be interested, because item Q is also visited by some other users.
Yeah.
Okay. That's interesting. Yeah. Okay.
Yeah. So it's purely just based on the links interactions.
Mm-hmm.
And I'm also thinking about that. So how can we include user features and item features in this? Right. So say if there's if it's a movie and there will be movie types, and maybe you can add a specific movie category node over there that kind of links all the movies like belongs to the same type. Add some complexity to the graph. I don't know whether that work, but I mean, it's one direction to think of, like how to enrich the graph, either by structures or by some properties, or how it can reflect in the link properties.
Yes, yeah. That's a good tie-in to our next session. So in graph neural networks, you can use not only the structure of the graph, but you're going to start with the node properties, and you can have a feature length of whatever you want. And so it enables that.
Okay.
So come back next session.
Okay. That's great. Yeah, because start to think about some item similarity that's only based on the item itself, image recognition and the product distribution NLP. But this link the user and item together, that's a good method. Do want to see more to not just treat each user's item equally, but add some features for modern purpose.
Yeah.
Great.